S.M.A.R.T. is a monitoring system for computer hard disk drives and solid-state drives to detect and report on various indicators of reliability, in the hope of anticipating failures. When a failure is anticipated by S.M.A.R.T., the user may choose to replace the drive to avoid unexpected outage and data loss. The manufacturer may be able to use the S.M.A.R.T. data to discover where faults lie and prevent them from recurring in future drive designs. Background: hard disk failures fall into one of two basic classes. Predictable failures result from slow processes such as mechanical wear and gradual degradation of storage surfaces. Monitoring can determine when such failures are becoming more likely. Unpredictable failures happen suddenly and without warning. They range from electronic components becoming defective to a sudden mechanical failure. Mechanical failures account for about 60% of all drive failures. While the eventual failure may be catastrophic, most mechanical failures result from gradual wear and there are usually certain indications that failure is imminent. These may include increased heat output, increased noise level, problems with reading and writing of data, or an increase in the number of damaged disk sectors. Work at Google on over 100,000 drives over a 9-month period found correlations between certain S.M.A.R.T information and actual failure rates. In the 60 days following the first offline scan uncorrectable error on a drive, the drive was, on average, 39 times more likely to fail than it would have been if no such error occurred. First errors and reallocations, offline reallocations and probational counts were also strongly correlated to higher probabilities of failure. Conversely, little correlation was found for increased temperature and no correlation for usage level. However, the research showed that a large proportion of the failed drives failed without recording any count in the 4-strong S.M.A.R.T. Warnings identified as scan errors, reallocation count, offline reallocation and probational count. Further, 36% of drives failed without recording any S.M.A.R.T. error at all, meaning that S.M.A.R.T. data alone was of limited usefulness in anticipating failures. PCTECH Guides page on S.M.A.R.T comments that the technology has gone through 3 phases. In its original incarnation, S.M.A.R.T provided failure prediction by monitoring certain online hard drive activities. A subsequent version improved failure prediction by adding an automatic offline read scan to monitor additional operations. The latest S.M.A.R.T technology not only monitors hard drive activities but adds failure prevention by attempting to detect and repair sector errors. Also, while earlier versions of the technology only monitored hard drive activity for data that was retrieved by the operating system, this latest S.M.A.R.T tests all data and all sectors of a drive by using offline data collection to confirm the drive's health during periods of inactivity. History and predecessors. An early hard disk monitoring technology was introduced by IBM in 1992 in its IBM 9337 disk arrays for AS/400 servers using IBM 0662 SCSI2 disk drives. Later it was named Predictive Failure Analysis Technology. It was measuring several key device health parameters and evaluating them within the drive firmware. Communications between the physical unit and the monitoring software were limited to a binary result, namely either device is OK, or drive is likely to fail soon. Later, another variant, which was named entirely safe, was created by computer manufacturer compact and disk drive manufacturers Seagate, Quantum, and Connor. The disk drives would measure the disk unregistered trademark S health parameters, and the values would be transferred to the operating system and user space monitoring software. Each disk drive vendor was free to decide which parameters were to be included for monitoring, and what their thresholds should be. The unification was at the protocol level with the host. Compaq submitted its implementation to the Small Form Factor Committee for Standardization in early 1995. It was supported by IBM, by Compaq's development partners Seagate, Quantum, and Connor, and by Western Digital, which did not have a failure prediction system at the time. The committee chose entirely safe's approach, as it provided more flexibility. The resulting jointly developed standard was named S.M.A.R.T. That SFF standard described a communication protocol for an ATA host to use and control monitoring and analysis in a hard disk drive, but did not specify any particular metrics or analysis methods. Later, S.M.A.R.T came to be understood to refer to a variety of specific metrics and methods and to apply to protocols unrelated to ATA for communicating the same kinds of things. Information provided. The technical documentation for S.M.A.R.T is in the AT attachment standard. First introduced in 2004, it has undergone regular revisions, the latest being in 2008. The most basic information that S.M.A.R.T provides is the S.M.A.R.T status. It provides only two values, threshold not exceeded, and threshold exceeded. Often these are represented as drive OK, or drive fail respectively. A threshold exceeded value is intended to indicate that there is a relatively high probability that the drive will not be able to honor its specification in the future, that is, the drive is about to fail. The predicted failure may be catastrophic or may be something as subtle as the inability to write to certain sectors, or perhaps slower performance than the manufacturer's declared minimum. The S.M.A.R.T status does not necessarily indicate the drive's past or present reliability. If a drive has already failed catastrophically, the S.M.A.R.T status may be inaccessible. Alternatively, if a drive has experienced problems in the past, but the sensors no longer detect such problems, the S.M.A.R.T status may, depending on the manufacturer's programming, suggest that the drive is now sound. The inability to read some sectors is not always an indication that a drive is about to fail. One way that unreadable sectors may be created, even when the drive is functioning within specification, is through a sudden power failure while the drive is writing. Also, even if the physical disk is damaged at one location, such that a certain sector is unreadable, the disk may be able to use spare space to replace the bad area, so that the sector can be overwritten. More detail on the health of the drive may be obtained by examining the S.M.A.R.T attributes. S.M.A.R.T attributes were included in some drafts of the ATA standard, but were removed before the standard became final. The meaning and interpretation of the attributes varies between manufacturers, and are sometimes considered a trade secret for one manufacturer or another. Attributes are further discussed below. Drives with S.M.A.R.T may optionally maintain a number of logs. The error log records information about the most recent errors that the drive has reported back to the host computer. Examining this log may help one to determine whether computer problems are disk-related or caused by something else. A drive that implements S.M.A.R.T may optionally implement a number of self-test or maintenance routines, and the results of the tests are kept in the self-test log. The self-test routines may be used to detect any unreadable sectors on the disk, so that they may be restored from backup sources. This helps to reduce the risk of incurring permanent loss of data. Standards and implementation, lack of common interpretation. Many motherboards display a warning message when a disk drive is approaching failure. Although an industry standard exists among most major hard drive manufacturers, there are some remaining issues and much proprietary secret knowledge held by individual manufacturers as to their specific approach. As a result, S.M.A.R.T. is not always implemented correctly on many computer platforms, due to the absence of industry-wide software and hardware standards for S.M.A.R.T. Data interchange. From a legal perspective, the term S.M.A.R.T. refers only to a signaling method between internal disk drive electromechanical sensors and the host computer. Hence, a drive may be claimed by its manufacturers to implement S.M.A.R.T. even if it does not include, say, a temperature sensor, which the customer might reasonably expect to be present. Moreover, in the most extreme case, a disk manufacturer could, in theory, produce a drive which includes a sensor for just one physical attribute, and then legally advertise the product as S.M.A.R.T. compatible. Visibility to host systems. Depending on the type of interface being used, some S.M.A.R.T. enabled motherboards and related software may not communicate with certain S.M.A.R.T. capable drives. For example, few external drives connected via USB and FireWire correctly send S.M.A.R.T. data over those interfaces. With so many ways to connect a hard drive, it is difficult to predict whether S.M.A.R.T. reports will function correctly in a given system. Even with a hard drive and interface that implements the specification, the computer's operating system may not see the S.M.A.R.T. information because the drive and interface are encapsulated in a lower layer. For example, they may be part of a RAID subsystem in which the RAID controller sees the S.M.A.R.T. capable drive, but the main computer sees only a logical volume generated by the RAID controller. On the Windows platform, many programs designed to monitor and report S.M.A.R.T. information will function only under an administrator account. At present, S.M.A.R.T. is implemented individually by manufacturers, and while some aspects are standardized for compatibility, others are not. Access: for a list of various programs that allow reading of S.M.A.R.T data, see comparison of S.M.A.R.T. Tools. ATA S.M.A.R.T. Attributes: each drive manufacturer defines a set of attributes, and sets threshold values beyond which attributes should not pass under normal operation. Each attribute has a raw value, whose meaning is entirely up to the drive manufacturer, a normalized value, which ranges from 1 to 253, and a worst value, which represents the lowest recorded normalized value. Depending on the manufacturer, a value of 100 or 200 will often be chosen as the initial normalized value. Manufacturers that have implemented at least one S.M.A.R.T attribute in various products include Samsung, Seagate, IBM, Fujitsu, Maxtor, Toshiba, Intel, S.Tech, Incorporated, Western Digital and Excelster Technology. Known ATA S.M.A.R.T. attributes: the following chart lists some S.M.A.R.T. attributes and the typical meaning of their raw values. Normalized values are always mapped so that higher values are better, but higher raw attribute values may be better or worse depending on the attribute and manufacturer. For example, the reallocated sectors count attribute's normalized value decreases as the count of reallocated sectors increases. In this case, the attribute's raw value will often indicate the actual count of sectors that were reallocated, although vendors are in no way required to adhere to this convention. As manufacturers do not necessarily agree on precise attribute definitions and measurement units, the following list of attributes should be regarded as a general guide only. Threshold exceeds condition. Threshold exceeds condition is an estimated date when a critical drive statistic attribute will reach its threshold value. When drive health software reports a nearest TEC, it should be regarded as a failure date. Sometimes, no date is given and the drive can be expected to work without errors. To predict the date, the drive tracks the rate at which the attribute changes. Note that TEC dates are only estimates. Hard drives can and do fail much sooner or much later than the TEC date. Self-tests: S.M.A.R.T drives may offer a number of self-tests. Short checks the electrical and mechanical performance as well as the read performance of the disk. Electrical tests might include a test of buffer RAM, a read-write circuitry test, or a test of the read-write head elements. Mechanical test includes seeking and servo-on data tracks. Scans small parts of the drive's surface. Checks the list of pending sectors that may have read errors, and it usually takes under 2 minutes. Long extended, a longer and more thorough version of the short self-test, scans the entire disk surface, with no time limit. Usually takes hundreds of minutes, approximately 1 GB per minute for modern drives. Conveyance, intended as a quick test to identify damage incurred during transporting of the device from the drive manufacturer to the computer manufacturer. Only available on ATA drives, and it usually takes several minutes. Selective, some drives allow selective self-tests of just a part of the surface. The self-test logs for SCSI and ATA drives are slightly different. It is possible for the long test to pass even if the short test fails. See also: comparison of S.M.A.R.T. tools, data scrubbing, disk utility, list of disk partitioning software, predictive failure analysis, system monitor, references. Further reading: Stevens, Curtis E., ed., ATA API command set, AT Attachment 8, 207A. S.M.A.R.T. Attribute meaning. Palixsoft. Retrieved February 3, 2006. Klondowski, Zbigniew. S.M.A.R.T. Site, Attributes Reference Table. S.M.A.R.T. Linux. Retrieved January 17, 2007. S.M.A.R.T. Attributes meaning. Aureolic 2007. Retrieved October 26, 2007. Can we believe S.M.A.R.T? HDS Hungary 2007. Retrieved June 4, 2008. Alon, Bruce. Monitoring hard disks with S.M.A.R.T. Linux Journal. Retrieved August 8, 2010. External links, UC Santa Cruz and Quantum Release S.M.A.R.T. Software for Linux, Michael Cornweller. UCSC Smart Suite, Source4G by Cornwell. How does S.M.A.R.T Tools differ from S.M.A.R.T Suite? Source4G. S.M.A.R.T Monitoring Tools, Source4G by Ballon 4705. S.M.A.R.T Tools and S.M.A.R.T Suite, smartmontools.org. GSMART Control as a GUI for S.M.A.R.T CTL by Alexander Sharjarai. How S.M.A.R.T is your hard drive? UK, pc-king.co. How to predict hard disk failure, 2010-05-19 with palimpsest, KB251, Understanding S.M.A.R.T and S.M.A.R.T. Failure and Errors, Western Digitala. How does S.M.A.R.T function of hard disks work? A. HDExpert, clear view of your S.M.A.R.T data.